distinguished guests, and ladies and gentlemen, good afternoon, and you all. Basically, I would like to extend my appreciation to Great Sir for inviting SESB to actually present our facts on the energy scenarios in Sabah for us to share today. Alright. So basically, my presentation will be focused on the view of SESB system, the interruption index that we use to actually measure interruption in the state. So you see what the performance on that as well, and then why major power plant is badly needed in the East Coast of Sabah. I will dwell a bit on that one as well, and energy option in the East Coast of Sabah especially. Okay, background basically. This is how we evolved basically. Mostly isolated station during 1984. You can see that even Sadakan is alone, KK, none of them actually interlinked except for Pangi towards Kota Kinabalu. There's a green line there. And then after that, 1988 we start evolving to have other plants as well, and then also interlink to Labuan as well. But still, the East Coast are isolated from the grid. And then came actually 2007 when we actually interlinked. So the scenario at the end of 2009, in fact not much different from now, is we already interlinked with East Coast via Sabah East-West grid connection. And basically we have interlinked already to the East Coast. Only the next step here is basically to establish a ring, which I will show in my next slide basically. This is the current situation in our grid of Sabah. Okay, and this is the future outlook. So we will have a second link, yeah, for East-West connection. So the importance of the second link is basically to establish redundancy. In case there's something wrong with this line here, we can always have a supply from this side as well. So the probability of happening for both sides are remote compared to only one. So I'm just telling you basically the future outlook and project that we have to actually improve our system from time to time. So it's a dynamic thing. It's a continuous effort. Okay. For now we have only 275 kV. That's the highest voltage we have, and the rest are still at 132. The blue one. So when you go further, you need a higher voltage, so that's why we need to have another line basically for the higher voltage transmission line. Okay, in terms of system performance, basically what we are trying to tell you here is basically we are improving. In fact, you can see from 2005 up to 2010, yeah, we are improving in terms of our interruption index. That we call them SID. SID in layman's term basically is in average, each one person in Sabah, and a consumer in Sabah, how many minutes do they experience in a year interruption. So we are targeting basically 700 SID, which I think I mentioned in various newspapers. And this target also shared with the ministry and ST and SSB of course. So basically those are the improvements shown. And then this SID 700 is overall for Sabah. Of course we know that in urban area, Kota Kinabalu and that, we have also target performance based on sector. So the demand is more in urban in terms of interruption because of the various activity or that kind of thing. Yeah? So we need to have a higher standard depending on the sectors. So that is to show the improvement happen. And then this is actually for this financial year. Our financial year starts from September until August. So throughout the financial year, we have a significant improvement, especially on the January and February. This actually is the overall, the total one. So if we want to achieve the 700 SID, we need to actually only allowable SID per day is only basically 2 minutes, something like that. So in a month probably it's about 60, something like that. So slightly higher on this, lower on that. So in average, we are basically around 800 plus for now. But because our initiative is still ongoing, inshallah we will bear fruit in later stage of the year. Okay. Okay, why major power plant is badly needed in the East Coast of Sabah? Okay. some of these slides have been shown by some other members, but for the benefit of other who are present here as well. So the situation in the West Coast is we have only slight reserve margin basically. And to say in the West Coast we have enough, sufficient, but very little as well. The excess is quite little also, but then the East Coast is even worse situation. There's a low reserve margin and shortage of available capacity as well if you based on the dependable capacity of the plant. So this is mainly due to the most of the development is on the West Coast, mainly due to the fuel availability there, which is gas. So the new plant, all that's built on the West Coast, and the East Coast we still maintaining whatever plant we have, SESB and IPP via liquid fuel. Yeah. So what happened is that the scenario is every time West Coast is helping out East Coast in terms of power, we have to export about 50 to 100 megawatt at any one time. Yeah. So we depend on the East Coast is now depending heavily on West Coast. Right. So what you don't want is basically if in case when East Coast East-West grid interconnection is lost, there will be no excess capacity available then from the West Coast, and thus East Coast will be operated on island mode. But even though it's on island mode, it's still not sufficient to cater for its needs. So we're talking about unserved load means load shedding, about 50% up to 100 megawatt. So this is just a illustration basically that in the West Coast grid we have 800 megawatt supply. This is the installed capacity, and then the West Coast itself will use up 600 plus megawatt for its own needs, and the balance will be transported to the East Coast, which requires about 300 plus megawatt. So, but 300 megawatt will not be sufficient based on the current situation now. The plant will not be enough to supply this. Hence the reason why we need a base load plant of such magnitude. Okay. Alright, again that's the by adding additional capacity in the East Coast, it will not address the shortage of power in the East Coast. We can plant up here, but it doesn't address this issue here. So what Sabah needs is a major plant in the East Coast to meet the demand basically.